Well, this here is a reverse scraping. This is the contacting thing, and I have already scraped it 2 times. So now what I'm doing here, I will blacken it all, everything, and after that I put it into the thing, rotate it for a while until it starts to squeal a little bit, and after that I will take it off and see where are my bright spots, and then I remove a little of material from those bright spots, and hopefully it will become we have contact areas everywhere. That's my goal here. Blacken the areas where we have something here. That one and that total. There you are. And now that's the correct way. Okay, let's see. Oh yeah. Okay, now you can see that we have high areas there, there and there. And now I will scrape some of that material away. It's very easy to do. I have here this utility knife blade. This is totally new. And I'm taking very small amounts of the metal off from here. Very, very, very small. Let's see what that does. Like that. And then put new paint there. And let's see if it is any different after this one. It should be actually quite different. Well, I can feel if in this way there are some, well, let's see what this means. And then this way up again. Okay. Well, it doesn't squeal at all. Is that a good sign or a bad sign? I don't know. Let's see how it is. Yeah, let's see. Now this is now exciting. Well, it has spread a little bit, and now we have this has been spreading and this has been changing so that now the high spot is only at this side, and then we have some new in the middle. Starts to look really good. So now I scrape a little bit more. Oh! Wow! Okay, let it run for a while. Should we run it on the other direction as well? It might also. It might be the reason why it's not touching the other side. Oh, well, let's see. Wow! Now we have a very good touch pattern here. Only this corner is now untouched, so I need to scrape a little bit from this area and that corner. And when we get this one, we are quite ready to accept. This is already acceptable, but because I'm pretty sure it wears in, but it takes some time. So I will now. Okay. Let's see. Okay. Now that you can see in the middle, we have a high spot in the middle here, and this is everything high, and that one is also high, and we are still missing a little bit in this corner. Well, it's over 50, and now I actually, what I will do here now, I will let it run for maybe 4 hours, and then I look again. There you go. Yeah. I let it run quite a long time. What I'm doing here is to drill a hole on the side into 2 pieces of this kind of thing. This is just some brass. It was a hex stock which I just parted in the lathe. Well, first drilled an 8mm hole there and then parted it. Then some filing, and there you are. And now what I'm doing here, I'm drilling a hole on the side, and this is to accommodate a cable like this. This is well, it's flexible, and this has quite large surface area. Actually, this is done from 10 couples of material. 10 couples of material like this. Well, I have just threaded, opened this like this, and then I have threaded them inside each other like an onion, and 10 of those. And well, one of these can easily handle maybe in a length of this amount, maybe, well, it's certainly more than 30 amps, but let's assume it's 30. And now when we have 10 of those, these can handle 300 amps quite easily. But you need to make that connection very, very good. And now, as it happens, the cable is a little bit under 8 millimeters. So when I drill an 8mm hole here and then solder this wire into that hole, that should do the trick. Okay, enough talking, let's drill. And I will do this manually. Just checking if it is true or not. It's not true. Okay. That's done. Next step will be a 4mm hole. And that one I will drill it from this direction, and this is where I feed in the solder. That hole is just feeding in the solder, and well, and this, oh yeah, okay. And the next one, so now we have a hole to put solder into there, into the joint, and the next one, position it the same way. It's about there. Oh yeah. Over and done. Yeah. Oh yeah. So now I need to solder these. Yeah. Well, welcome to my soldering station. So what I'm doing here is to solder using this metal soldering iron. The paperwork you are seeing here, this is just thermal insulation, so that because copper is a very good thermal conductor. So now it will heat up, but it doesn't dissipate the heat in the environment, so it should, well, we should be able to warm this up enough to be able to solder it. Let's see if yeah, it's already wetting, so it takes some time to, yeah, it takes some time. You just need to be patient here, not to become one. Oh yeah, it's still warming. The solder will be sucked in by the capillary action here. So, oh yeah, now it went in. We have to be careful not to put too much solder in there. Okay. Let it cool down. Well, this soldering iron is 50 watts, and the whole power is concentrated into the tip. This is a very good thing, and you can do things like that. I need to see that I don't. Now we need to let it cool down. Yeah. There you can probably see that's also our soldering, and it's all over the place here, and it's the solder has penetrated up to this point, I believe, because I can see it starts to flex there. So, well, and then I also have marked here place where to cut this now. And well, you could use side cutters for this, but the result wouldn't be very nice. That's the wrong way to do this. So the correct way is to do it gradually. So I will start by nipping the outside, just tiny amount from the outside. This was done as a onion, so we have layers here. Okay, now it's enough. And the rest with scissors, actually. There you go. Now it's a lot nicer, hopefully. And of course this needs to be quite clean. And now this should go into there without... Yeah, it went in, but it must go all the way in. Yeah, now it's all the way in. And these must be about in the same plane. So now, well, now we are all in the same direction. I also found out that the thermal insulation, well, it's needed, but it's not so critical as I thought. Yeah. So now I will start soldering this one. And now I can see from, because this was the one that had the hole through. And I have too many tools on my desk here. Okay. So now I just do the similar process as I did that with that one. So I start warming it up, like here. And this takes some time. It's just time consuming. So I need to wait. And I don't want to use my butane torch for this one, because with this way you can control the temperature more precisely. And oh yeah, now it's starting to warm it up really. So it's easier to control the temperature this way. If you use a butane torch, then well, you can end up heating it too much, and the soldier will creep all the way in, and then it's no more flexible. Oh yeah, and that's... Yeah, it's heating up. Heating up. Now it's starting to go into there. And we have the hole full of lead. I mean tin. Let's take this one. Well, I can always drill that. Is this hot? No, it's not hot. Oh yeah, I can see that it's fully penetrated. Well, but this looks now nice. Okay, let it cool down. Okay. The grounding wire will be attached to this body. Well, there will be an M8 thread and a flat. And those are exactly the things we are going to do now. But how I have attached this here, I have already done this once when I milled the hole into this piece, and I'm now using the same method. So it is well, a 2-clamp here and a machinist vise to keep it from rotating. And the same in this side. So now it is just to drill the hole. This is the diameter of diameter of this drill is 6.8 millimeters, and I will drill it all the way through. It's the tapping size for M8. So. Well, I hate these helicopters. They are really loud. We have some more to go, but not a lot. Oh man. Ooh. Okay. Next step, we will do the flat here. And that will be, well, I'll check the diameter of the flat and let's see what we can get out of that. Now I'm going to make the flat in here, and well, I would like to share this setup with you. So, well, I'm using the Wohlhaupter planing and boring head. Boring, planing, planing, boring. Okay. Anyway, you can plane with this one. It means that you can actually feed radially. Yeah. It's exactly the job which this tool is intended for. And so now I have drilled a hole there in between 6.8 millimeters, and I measured how much do we need for this brass nut here as a flat. It's 35 millimeters. Then doing some math, we end up in a radius of 14.1 millimeter from the 6.8 millimeter edge. I will show you. I will bring you a little bit nearer and I will show you what this is. So here we are. So my calculations are here. 35 millimeters total diameter. Then we subtract the existing hole from that, the diameter of that, get this figure, divide it by 2 and end up in 14.1 millimeters. Meaning that the distance from the edge of this 6.8 millimeter hole to the edge of the flat area should be 14.1 millimeters. Well, there are different methods of doing this, but this one is easiest in this point for me. Yeah. So now what I'm going to do next, we are going to adjust, these are the stops. These things here are the stops for travel of the radial feet. So let me change the camera and show you when I adjust these in place. I will adjust the travel when I retract it. When it has been cutting all the way, then I will retract it, and there is one adjustment for that limit. It's this one. Well, I think it's about there. This is not exact, so I set this, lock it there, like that. And now it won't come any farther, it stops there. Okay. Next step is to adjust the other one, this one. Hopefully I have enough travel there. Man. You need to milk this thing. Now I will actually raise the table a little bit so I can see the scratch. Okay, there you are. It's a little bit of shine. Oh. Little bit more. I want the whole black line to disappear from there. So that's our other limit. And we put it there. Like that. And it won't go any farther than that. Yeah, it stops there. So now, and since this was I can reset the Z now here. So one final check that we are tight. Okay. Then this tool has controls. this knob here is used for the revving, and this I will now disengage like that. Now what this does, it only locks these two rings together, and well, now we need to retract it actually, so I will lock it back. So let's retract, let's retract, yeah. Well, let's engage a gear. So the speed. Well, the problem with this one is that the cutting speed increases dramatically because the radius increases. So maybe 100 revolutions. I will set the speed first here. Okay, that's now 100 revolutions per minute. And now we have the lock here. This is always a little bit. And when I rewind it, I just hold here and it will rewind. Like that. And it will stop when it's fully retracted. Like that. There you are. And now, since we have this wheel here is the a locking mechanism that we don't use at this time, and now it's wrong orientation. Okay, so now I disengage the revving and engage. This knob here is for engaging our feet. And now this will be our first layer. So let's take 0.2 millimeters. I don't want to, I just want to see what happens just scratching here. So let's go. You hold from the upper part of here and it should actually, yes it does. Was that really half a millimeter? Looks a lot more, but well, no, it's just there you are. Stop this and disengage the feet. The feet can be disengaged by pulling this up, and then I can engage the reverse, and then just do the reverse. This goes a lot faster than the feet. There you are. And well, the first is there. It created a horrific burr there, but well. very decent flat. Okay, well, a lot of deburring to do here. There is a horrific burr around the hole, but the flat itself is really nice. Okay. Well, the next task is to break this M8 tap into that 6.8 millimeter hole. Well, traditionally this is the place to do it. So what I'm using here, this is my automatic center punch as tap follower, because I couldn't get the actual tap follower inside there. And this is the tap in question is a gun tap, meaning that it's pushing the chips down in the hole, and since this is a through hole, well, that's exactly what we need. This should go without, and you can feel it cutting really freely. So there is, hopefully I don't break the tap into there. And you can do this in one go. So. And of course our tap follower is no more following, but this one is keeping itself straight. So we should be through quite soon. Oh, it feels a little bit crunchy down there, but we are through. Yes. I'll take this off so I can, well, take this off. Oh, like that. Works. So now let's just take the tap out from the hole. There you are, M8 thread. Now let's just try it out. Should be, yeah, it's perfect. As always with a decent tap, there is nothing fancy about a threading thing like that. And the tap didn't collect any chips, they are all inside there. This is the tap I was using. So it is actually cutting on the top here and pushing the chips into the hole. Very good choice for a through hole tapping thing. Yet another flat. This one will be done the same way as the previous one, but this is now for the shaft that is in 90-degree angle into the base. It will be holding this thing and can be rotated. So now I will do this recess. It will be a little bit deeper than the other one. But the principle is still the same. The speeds are the same. Everything is the same. It's just different hole and different dimension. It's 40 millimeters in diameter, this one. And I probably need to engage the drive. Like that. Now it should work. Well, at the moment we are here 1 millimeter under this surface here. So, but I would like to take 4 more millimeters. So it would be 5 here and a little bit more here. So that's my aim here. And now I have already like I think I have the next, and I'm taking 0.5 millimeter cuts here. It seems to work just fine with that. So next 0.5 millimeter. Okay, and what I will do now, I will clean the sides by normal boring. For this reason I tighten the lock here, and then I just manually feed it the table down, slowly. This way we might get rid of some of the ridges there maybe. Trying to sing on me. That's fun. And yeah, the surface finish on the sides is super. And well, the bottom is what it is. Well, now next step will be to diffuse this setup and then do a lot of deburring. Now we have the cable here. There is one thing that is now when I see it in its place, it's really obvious. I cannot leave it like that, because the first thing the welder will do, he will clamp the grounding clip into this one. I'm pretty sure of that. So therefore I will put some maybe some plastic cover on here. Let's see, I will do that, so that it no more is option to put your clip here, because this is so in a so obvious place that you most certainly will do that, and this is quite delicate. It can handle probably 300 and some more amps, but it cannot handle, if you put your clip here, it cannot handle the mechanical stress. So that's one. And this one, well, it went well. Actually, it's a nice looking thing, and well, Wohlhaupter is really a good tool. Well, I already know what we have in our next episode of Finno machining. My Dremel is broken in a way that it's not running, it's trying to run, but not running, trying to run, not running. There is probably a capacitor inside that has well, given up the ghost. This one has an electronic controller, and that one is probably the culprit here. So I will fix that one if I can. Hopefully I can. And yeah, but this one will be in the next episode of Finno machining. And as always, see you!